Hi, welcome back to Texture channel. So in this Java intro questions, we're going to discuss about another um, important the fundamental question asked to all the Java developers to understand how good knowledge he has about the Java memory management, about the different layers in Java memory management, and what will be how the garbage collection works in each layers, and how the developers can handle um, the memory related issues, and what is the how he considered to allocate the memory for each layers, right? So these are different things the panelists want to understand from the developer. So let's get into the discussion. So this is how the memory stack looks before Java 8. So we have a stack memory and we have a heap memory. The stack memory actually stores the variables you use inside the method, and the heap actually stores the actual objects. And in the heap you can see different segments like int generation, old generation, and perm generations. So let's see what those layers are, right? So the int generation, let's say like I'm creating the object for the first time, so those will be moved into the hidden memory. The garbage collection always start the collection from the hidden memory, and if there is any object surveying uh, from the garbage collection, then those will be moved to the surveyor memory, so from which it will be garbage collected then later on. If there is any object with a long lifespan, then those will be moved to the old generation memory. So that is how the objects are moved between the young generation and old generation. And we have a perm generation. So the perm generation actually stores the metadata of a class. Also it stores the string intents and string intents. Okay, so those information will be stored in the perm generation. So that is how. So this is how the memory stacks of um, the Java looks before Java 8. But when the Java 8 come in picture, they did some changes in this memory stack. So one of those is moving the perm generation out of the heap. So they moved the perm generation to the meta space. So what is the advantage they achieved because of moving the perm generation out of the heap is like the perm generation actually, it stores the metadata of your class, right? So let's say like your application is too big and it depends upon too much of libraries. So when you start loading your application, you need to load too much of metadata, so which may end up in you know um, filling up your perm generation, because being part of heap, you will be setting what is the maximum memory, right? And it is there is a lot of possibility that memory may get filled. Okay, and if once they get filled, the garbage collection need to start working on your perm generation to clear out all those memories, right? So which takes long time, and because of that, because of all these things, there may be a performance issue. Okay, so to avoid that performance issue, they moved the perm generation to out of heap and they named it as a metaspace. So the metaspace is created on the native memory, which can keep growing. Like if let's say like initially you have like 2 MB of metaspace, and once you reach the 2 MB, it can keep growing to 4 MB and 4 GB. Then it can keep growing like that is a major advantage of moving the PAM generation to the metaspace. Okay, So this way, like the performance of the application is not impacted. And the other change they did is they added a heap memory in the indentation. The purpose is so they don't want to impact the fresh objects like to be eligible for a garbage collection. So they want to keep it for some time the memory. That is the intention of having the keep memory. So whenever the objects created for the first time, it will be stored in the heap memory for some time, and then it will be moved to hidden memory from which the garbage collection actually start working. Okay, so that is the purpose of having the heap memory. Yes, so that's all about how the stack looks like. Okay, and so here is different ways how to allocate a memory. Like say, like if I want, when starting the application, if I want to set some memory for a heap, I can use this SMS parameter, and smx is and the maximum size of my heap, and the PAM size is the argument which I can use to set the PAM space size, and to set a meta space I can use the max meta space size. Okay, so yeah, like so after moving the PAM's generation out of the heap and throwing it to a native memory, still we need to handle the meta space. We need to allocate the memory for the meta space. What will happen if we are not allocating, and your program may be occupying too much of memory in the native space, and that may end up in some other issues. So it is better to allocate some memory, okay, some maximum memory in the meta space. So that is why we are using the max meta space parameter. Okay, so these are the different JVM parameters. When you start in the application, you can pass these parameters, or you can set these as environmental variables. Okay, so these are few different types of exceptions which may occur because of the issue. Okay, so the one is stack overflow exception. So we all know, like, the stack contains the variable that are declared inside a method, right? So the stack overflow normally happens if, let's say, like I'm using a recursive function, and the recursive function is trying to call another function. So in this recursive end up in some infinite loop. So what is happening? My stack is overflown with this storing the same methods again and again and again. That is why you may end up with a stack overflow exception. Then you need to go into your code and see why that infinite loop is happening. So you need to fix the infinite loop and to resolve the stack overflow exception. And the memory out of memory exception or PAM space exception, it's because, like, maybe because of the memory leak. It's like for example, like you got a connection pool object, okay, and you forgot to release the connection pool, okay. So you are storing that always in your memory, right? So every time when you get a connection, you're creating a new connection pool object, and you keep storing that in your memory. You are not releasing it, right? So that may end up in your memory leak. That's just one example. There may be many other use cases. For example, like if you use too many of static variable, that also end up in out of memory exception. Okay, so these are different exceptions that may happen because of some unclean code, okay. And how to find, okay, how your application is performing in terms of memory, right? How much memory your application is actually eating, right? So how to find those things? You can use the JVM itself is providing the utility, right, like JStat, JMap, and in ID like Eclipse or NetBeans. They also providing profilers to find out like how much memory it is using and where it is actually consuming more memory, and like which class and which method is actually eating up more memory. So all those profiling you can do using these utilities. Okay. So actually, from my experience, okay, so even I have been working some of the Java based batch jobs, okay, which need to process too much of data. Okay, so how we handle, okay, from design perspective, we will analyze like how much of data I'm going to uh, play, right? So based on that, we allocate the memory um, when designing the job itself. Okay, and whenever there is any issue, we get that dump from the production support team. From the, like, if there is any issue in the production, okay, we get a memory dump from the production support team. We study the memory dump to see where the issue is happening, and based on that we fix like that particular class or object, we fix that. That is how in real time we handle the memory issues. I hope it is a useful section for you all, guys. If you like this session, subscribe to my channel. So I'm planning to add more sessions on the same topic. So yeah, so please subscribe to my channel, so you get update about the future sessions. Thank you.